Problem 815. A girl weighing 500 newtons jumps from a tree. Inner center of mass falls a vertical distance of 2 meters. Find the impulse necessary to bring her to rest. Over what time interval must the deceleration last in order that the average force does not exceed 200 newtons? Well, let's draw an overview of the problem. The girl has some mass m, and she falls some distance h. The potential energy that she loses as a result of her mgh, if I define my reference line right here, this is the GPE reference, is going to be converted to kinetic energy, which will allow me to calculate what her v is in this direction. Let me define a coordinate system that is positive going up. And so the impulse necessary to bring her to rest is going to be the delta P. So her momentum when she just before she hits the ground is going to be equal to her mass times her velocity. And so the first thing is, let's calculate her mass. We're given her weight, not her mass, and so her mass is equal to 500 newtons divided by g, 10 meters per second. So her mass is 50 kilograms. And her p, momentum, downwards when she hits the ground here, her p is equal to, well, that's going to be negative. It's downwards. And so it's going to be the mass times her velocity. So it's going to be m times v, and I can calculate v from conservation of energy. So I can say that the initial potential energy is equal to the kinetic energy just before she hits the ground, 1/2 mv squared. And that allows v to be calculated. V is equal to the square root of 2gh. So that's equal to 2 times 10 meters per second times 2 meters, which is equal to about 6.3 meters per second. And so for the p that she has right here, we'd better put a minus sign on this. The v is down. I had a choice for plus or minus here, and minus is the correct choice. So the p is going to be equal to 50 kilograms times minus 6.3 meters per second. So in other words, that's equal to minus 315 kilogram meters per second. And the impulse necessary to bring her to rest is going to be p final minus p initial. Where her final is going to be 0 kilogram meters per second, minus p sub I, well that's the p that I calculated here, minus 315 kilogram meters per second. So in other words, delta p is equal to 350 kilogram meters per second. As expected, the impulse required is going to be upwards. That's the delta p. Has to be upwards to stop the p that was initially downwards. And then the second part of the question is, over what time interval must the mass deceleration last in order that the average force does not exceed 200 newtons. So we'll use the impulse momentum theorem to do that. We'll first of all state that F average times delta t is equal to delta p. And that means that delta t is equal to delta p over F average, which is equal to 315 Newton seconds. Newton seconds now instead of kilogram meters per second, so I can get the right units for delta t. And then 200 newtons. And that gives 1.6 seconds. So note that this F-av is also up. F-av has to be in the same direction as delta p.